All right, we're going to get started here in a minute, folks. Cool. All right. Hey, everybody. So we're recording right now on the Zoom. Thank you so much for coming. So if you don't know already, I'm Doug Meal. I'm the founder and organizer of Cleveland Big Data. So again, thank you so much for coming. So we've got 3 great talks today. Yes, I do say that every meetup, but they are all great. And so we got Chris Conry with time series data manufacturing. We got Angelo Trivisonno with accessing open data from local governments. We got Sean Carruthers from Databricks talking with analytics with the Unity data catalog. Announcements. So the announcement I like to remind everybody. So if you do a talk at the meetup, you get an honorific called a friend of the show. Notice the trademark. It stays with you for life. You can put that on your resume, put it on your business card. You cannot gift it or will it to anyone. So it's like a life peerage. But it does stay with you for the rest of your career. If you would like to be a friend of the show, let me know. So we're always looking for speakers. We're always looking for new content. If you have any suggestions, please hit me up. We're also always looking for pizza sponsors. So if you also have an interest in sponsoring a meetup, it doesn't take much. We just need a free room and pizza, and this crowd is pretty easy to please. The March meetup is going to be at Baldwin Wallace. The May one is going to be a Progressive. I forgot, I didn't add that in here. So we've got the next 2 lined up. We still haven't lined up July yet. We're aiming for another mega meetup for September. We'll keep you posted on that. A few other ACM blogs again. So for those that don't know, I've been doing a lot of hobby nerd writing in the last couple of years. The last one I wrote was Inorganic Growth in Tech Getting Shredded with Acquisitions. That's up, and also the Data Governance and Psychology Attention Management. Both of them got a fair amount of reads. So again, if you're interested in those topics, please check those out. Recruiting shout outs is an important part of the meetup. Nobody hit me up with any, but I would do want to at least give folks a chance for anyone that's here. Anybody have any recruiting shout outs? Anyone either looking for anything from the hiring side or looking for anything from the I need a job side? Please, if you got anything to say, stand up and say it. Anything? Nobody hiring? This is bad news. Oh, one. Wait a minute. I didn't see the comment. Could somebody read it? Chris, any of the other speakers, can you see the comment? I apologize. I'm having a hard time finding out where the what was the announcement? Okay. Whoever's online, could you do a chat to the panelists, please, with whatever you were going to ask? All right, going once, going twice. Oh, wait, I see it in the QA. Okay, well, we're going to have to go on here. I'm not sure what's going on, but yeah, I don't know what. Yeah, we're going to have to go on here. Sorry about that. I don't know why it's disabled because it normally is not. So again, we've got a lot of key thanks. RoviSys and Databricks, thank you for RoviSys and Databricks for sponsoring the pizza today. Everybody give them a round of applause. We literally could not do the meetup without pizza. Secondly, Sunny, I don't see Sunny here today from Cleveland State, but again, thank you for Sunny for letting us use the ballroom here. So again, big thank you for Cleveland State. Linux Foundation, John Murdoch and the Linux Foundation, they're letting us use their Zoom to do the virtual meetup and also post it on the Linux Foundation YouTube site. So again, big thanks to John at Linux Foundation, and again to the Cleveland Big Data members. So with this, Chris Conry is the first speaker. And again, don't forget, if you have anything, you'd like to see in the meetup, please let me know. We're always looking for speakers. So come on up. Just go through your Zoom. Yeah, okay. I'm just using the Zoom. Perfect. And I'm gonna mute mine.
I'm connected to audio. Is that good? Okay, I see it lighting up, so that must be good. Oh, and I need to share my screen. Sorry. Okay, you can see that in Zoom. Awesome. All right. So I've been going to these talks for a number of years, and I've been seeing a lot of like IT space and financial, and it's great. It's a lot of what's going on, but it's not everything. In the manufacturing world, we have a little bit different experience, different technologies, and I think our relationship with something like time series data is a little bit unique. So that's why I chose that as a talk. Just to kind of overwhelm everyone, talk about something near and dear to our heart, manufacturing, the S95 chart. This will mean nothing to most of you guys, but in manufacturing and automation, there is a standard for how you go about things, how you collect data, what type of technologies you use, how things move up within layers. There's standards defined back in the 70s that evolve over time, but we really kind of follow the same practices in every single industry. I've worked in industries from pharmaceutical to oil and gas to steel, you name it. And there's a lot of things built in this room that I've actually seen the plant, bigger than this campus to make. So it's really incredible some of the things in manufacturing that they all boil down at the end of the day to this S95. But when it comes to where the data comes from, it's all going to come from the bottom, right? It's all going to come from the sensors. And that's really that level 0, 1, 2 is what we call it. And it's the process control area of manufacturing. So I don't think I could talk about manufacturing and how we get our data without talking about process control and process control theory. It's something that's very simple. It's something that you basically have a set point, and it's about running the equipment, maintaining temperature, pressure, whatever it may be, to get to that set point consistent. Whether it's making mRNA slurry for the COVID vaccine, whether it's refining oil and keeping that at a particular temperature to condense. It's always about having a set point, running equipment to get to that set point. There's three basic examples that I always, when I talk to people about like the fundamentals of what we do, it's your cruise control. You set it to a speed, and no matter the incline, the decline, no matter what it is, your car is going to keep it at that speed. Your car has a process loop. There is information that goes into it, and it decides to react in a particular way to keep it at that set point. Your hot water tank, as you use hot water, and as cold water comes in, that's going to change the temperature of the tank. What that hot water tank is doing is it's using a thermocouple to keep it at a particular temperature and regulating it. So that process control is really the fundamental of manufacturing. We take a lot of processes and we control them really tightly, and then we expand and build upon that to make more complex systems. And then finally, thermostat. That's pretty self-explanatory given all the other ones. There's two types of process control systems. The first is PLCs, programmable logic controllers. The second is DCS, distributed control systems. These will make up most manufacturing. I mean, I can almost guarantee it. PLCs are good when you want to control one process. Say I have a crusher that is crushing rocks as it comes in. What you'll do is you'll throw steel balls into that. It's almost like a dryer drum, and it breaks down material. You'll have a PLC control just that, versus like a DCS would be good if you're doing batch manufacturing for something like the COVID vaccine. Communicating plant-wide, understanding how things are going to be controlled as things move through valves. So it's two different type of control systems for two different types of needs. And these have been around since the 60s and 70s. This is not a new technology. This is almost a pretty antiquated technology. It's funny, we'll have projects where engineers will go and replace control systems that are older than them. And that's insane. But these control systems will run nonstop 24/7, 365, rain or shine, and they don't patch, they don't crash. They're very resilient. And that is the heart of manufacturing. What you'll notice at the bottom of these graphs is you'll see a bunch of devices. You'll see, the thermocouples, motors. You'll see light sensors. You'll see a bunch of different devices that are used to be part of that control loop. So in the example where the cruise control, that the speed that comes in is part of the control loop to understand, hey, my speed is decreasing. I need to increase the RPMs of the car to get back up to that speed. All of these different devices will be a part of that control loop to maintain that process, but all those devices are also providing data. And that data we can collect, and that data we can analyze, we can use it to troubleshoot problems, and it's really, really powerful. That data can either be analog or digital. There's different types of devices that provide different types of data, but it's really, really insightful, the amount of data you can get. So you have all these devices that create data. The question is where does it go after that? For us, it's historians. Historians, raise your hand if you've ever heard of a data historian. Awesome, very few people, which to me, when I started RoviSys, I hadn't heard of it. But these historians are really, really unique, and they solve some challenges that I don't think a lot of people understand how important to just manufacturing that this is. So when I was talking about the sensors that they collect and they create that data, that is coming in milliseconds. And for some processes, especially in the defense industry, they'll come in nanoseconds. And you need to collect that. You need to collect it as is, and it needs to come in at a certain fidelity, and you can't lose it. That's a lot of data. I was talking to some of the engineers at a steel plant down in Alabama, and I asked them, I said, okay, well, what are you using for your historian? And they said, oh, well, we're just throwing it into SQL. And I was like, wait, you're throwing all of your time series data into a relational database. How big is that? He's like, well, it's about 5 terabytes for the past year. And I was like, That's it. And I was like, well, then what do? Do you archive it? And he's like, no, we delete it. I was like, so you have no insights into your business past, a year, because it takes up terabytes. And that's hard, because they wanted to do this, preventative maintenance, machine learning project, and we're really excited, but didn't have the data for it. And so that's hard. So I have to tell them, hey, you have to install a proper data storage mechanism, and then we can talk in about 3 years. That's uncomfortable, but that's the reality of it. There's a lot of these different historians. One of these, Rockwell, actually over in Mayfield Heights, Factory Talk. There's more than this, but these are the ones that we use very frequently. They all have different pricing models. They come with different features. They solve different needs. More industries see different types of historians than others. But at the end of the day, it's all collecting about high fidelity data, storing it and compressing it in a way that is, able to be maintained long term, and then providing access at a higher level, right? So there's that S95, where it goes up different levels, being able to provide that data through APIs, SDKs. There's an OLED B interface for the OSI Soft Pi one, which is really powerful. You can do store procedures to hit that historian. It's really nice. The features of a historian are pretty unique, as well as modeling, because when you collect data, you're collecting just the raw tag. You're collecting, this is this point, this is just this one sensor, and it's coming in every millisecond, it's making changes. It could be the vibration of a motor, right? Motors, when they're running, they're vibrating very frequently. Being able to measure how much that is vibrating, whether there's a certain amount of power going to it, whether there's a certain amount of torque it's expected to provide, will have an effect when we start to do analytics downstream. So being able to collect all of that data reliably is really important. So kind of wanted to give a couple examples of this. This is one of the ones, two of the ones I'm a little bit more familiar with. This was this used an OSI Soft Pi historian, which was to create an enterprise historian for a major pharmaceutical company. Let's just describe it like that. It was 2.4 million tags. So there was 2.4 data points being collected at various frequencies. It could be every second, every millisecond. It could be every time that data changes, which it might only change. It could be like temperature of room. Temperature of room doesn't fluctuate a lot. It might be every 15 minutes. But it's collecting all of that data, all 2.4 million tags. And then 150, the senior engineer told me it was more like 200 asset templates. So that every asset is, if you have a tank, so see each one of those tanks, that will have a pressure, that will have a temperature, that will have a volume, how much it's filled up, flow in, flow out. There's each one of these tanks could have 30 different data points. So what we'll do is we'll model it. We'll build asset models. And whenever we have different points come in, we will assign those to those asset models. And that just makes our data modeling and organization a lot easier. But about 150, 200 asset templates. And then at the end of it, 14 terabytes of data for this company. Now it was, I think there's at least like a dozen sites nationally, if I'm not mistaken. So it's a lot of plants. This is a very big pharmaceutical company. But it's, the scale of this data that we have to work with. If we stored this in a relational database, it just wouldn't work. And we've actually seen some of these challenges when we start to work with the cloud, which I'll touch on later, how it doesn't kind of one-to-one translate. Another experience is building a machine learning model for natural gas utilization. So this is actually a project of mine where we used historian data to basically predict how natural gas had to move around within substations for a natural gas provider. So the temperature of the weather kind of told us that. We knew residential houses needed to be heated more, so substations that supported those residential houses had to move certain volumes of natural gas out more. And we can tell that with the data. So we built predictive models to say what the demand was going to be. And it worked out really well. It was a really successful project, but all of those data points down to the weather data, weather was stored. They took it from a service and they stored it down to their historian at a certain frequency. So all that data came from a historian. And then we did some feature engineering, did some lagging features, but we were able to predict demand pretty well. So that's a lot of what has been. Talking about a little bit what is going to be. This Industry 4.0 thing, it's a buzzword in manufacturing. That's what they all love. But it's kind of the futuristic way to look at manufacturing. And they define it as 4.0 because they categorize it, first as the first industrial revolution with steam, then we move to electricity, where we are, maybe early 2000s, third, and now the fourth industrial revolution. So what does that look like with time series data? Where do we see that being used? First is the Internet of Things. So when I talked about these sensors that were collecting individual points of data, they had a really single responsibility. Sounds a lot like IoT. It is a lot like IoT. So it's really challenging manufacturers to think, okay, we have a lot of these temperature sensors off the shelf that work pretty well. Why am I paying $1,500 for a thermocouple? Does it make a lot of sense? So IoT also allows them to use things like MQTT to get it up into the cloud real fast. Maybe from a velocity standpoint, I need to consider those things. So IoT is really like, it's giving manufacturing a real identity crisis. They really want to use it. They're really scared of it. There's security concerns. No one knows what to do. But it's a real challenging part of this. And you will see a lot of those IoT devices communicate with OPC to write data into a control system the same way. The next is cloud and what we call edge capabilities. So AWS has a whole manufacturing division that we work really closely with, both to get products to move in a particular way, to give them feedback about how their products work for our space. But what we see a lot is this term of edge, because when you build a plant, you don't build it in a thriving city. You build it in, the middle of nowhere with poor internet connections. So having a good high-speed internet connection is not a luxury that all these manufacturing facilities have. So having things that are on the edge and can buffer between the plant and cloud is really, really important. So there's a lot of things that the different cloud providers are doing and providing to support that, but it really is challenging. But that previous pharmaceutical one I mentioned, that actually was all in AWS, if I'm not mistaken. So the manufacturers do like to use the cloud, but there's security and frankly, internet issues. Third is I have to mention Bonsai is a product that I work with Microsoft really closely on. We're a partner with that. We're using this time series data to provide simulation modeling. So if I know how a plant works, if I can collect these millions of data points, I can create a simulation to determine how that plant is going to work and use a deep reinforcement learning AI to train through that simulation to discover optimal ways to run manufacturing. It's been really exciting to work with Microsoft on that. And it's time series data with how crazy ubiquitous it is. We're seeing a lot of impacts that it's going to have on like deep reinforcement learning. And finally, I just want to show there's an SK time library now. That was like, I don't know, I felt seen. We have all this time series data. There's the SK Learn, there's PyTorch, there's all those modeling libraries available, but they're creating time series ones. And that felt really good to kind of see the community, the larger dev community, come back to an area that maybe has been overlooked. With that, got about 3 minutes for questions. Anyone have any questions? Yes.
Pretty cool thing. I think what we're talking about here is time series data is back of historical or running simulation test capacity models is back. Maybe it's a different talk when we come back and talk about real-time predictive time series, like in the example I think we talked about refineries or Stuxnet, right? When we're misreading nuclear gauges because of malware, you need real-time to use AI to somehow help with mitigating risk for industrial controls.
For sure. And so the question was about like critical infrastructure and could this time series provide insights into, issues with that? Yeah, 100%. One of the actual time series use cases we had was with a particular pipeline that had an issue recently. They're a very big customer of ours, and actually the reason they never lost control of the pipeline is because of the network segmentation that we provided to them. So yes, they have a lot of historical data. They're very good about that. So yeah, it's definitely used if especially right with the Stuxnet example, it's used to go back and understand why issues may have occurred. Any other questions? I don't know if there's any online.
What's the underlying data structures to those stories?
Yeah, so yeah, so that's a good question. So yeah, so the question was what underlying structures are they using for the historians? All different ones, good and bad. I think the OSI soft pi, one we use a lot, has their own proprietary thing, but it's amazing at compression. You'll see some of them that are basically just like SQL bolt-ons, not as good per the compression reasons I listed before. But each one of those historians, it kind of depends on what that development team decided to implement. Yeah, they're all different. Some good, some bad, some have strengths, some have weaknesses. Yeah, usually affects the pricing model. Cool, perfect. All right, nailed it. All right, thanks guys.
All right, next up is Angelo Trivisonno. And he's going to get ready. And whenever you're ready, Angelo, I'll mute myself. And the chat functionality, I believe, should be working. If anybody has any questions, who's online, we got a decent crew there online. Let me know, and we can try to shout out the questions during the talk at the end. Yeah, just unmute yourself. There you go.
Okay. Hey, everyone. I'm Angelo Trivisonno. It's nice to be here with you all. Let me just get rid of this little floating meeting controls here. This talk, I know the agenda says something like accessing public open data from government websites. This talk is actually a slightly expanded talk from one that I gave a few months ago. I recognize some familiar faces here that were at a Data Days Cleveland event. So hello again to you all. This presentation is a quick discussion of using public data, sharing it via Twitter bots. Quick question, who here has a Twitter account or has used Twitter? Is it a lot of you? Is it not a lot of you? Is there a lot of addiction here? Okay, so a healthy number, 60% or so. So we're going to, I guess, just as a first thing here, what is a Twitter bot? So first off, Twitter is a social media platform. If anyone's heard the name Elon Musk, you should at least recognize what Twitter is and how to get there online. And a Twitter bot is essentially an automated account. Twitter is comprised of accounts. People can have accounts, organizations, governments can have accounts, computer programs can have accounts. So it autonomously performs actions, whatever you program it to. So if any of you know a programming language, almost any programming language, you also yourself can create a Twitter bot to do almost anything that you want, as long as it doesn't break the rules. So we're going to talk about 3 bots that I made. I live here in Cleveland, and I'm involved in a wide variety of things. I really like local government policy. I also enjoy riding a bicycle, and a lot of my friends ride bicycles, so I'm interested in safely getting from A to B or A to A via bicycle or just on foot. So I wanted to create 3 Twitter bots to do very specific things that I just did not have time myself to do. So the first one is called the Cleveland Bill Bot. You can find all of these on Twitter, and you can follow them if you want. The Twitter Bill Bot, if any of you, what's like the song? What's the show that this character is from? Schoolhouse Rock. Thank you. Yeah. So basically what this does is this tracks Cleveland City Council legislation. I think that local ordinances, laws, they're kind of like the code to civil society and to government. So I'm always interested in how it's being tweaked, how it's being changed, what proposals are, what the discussions are, and I want to hopefully encourage as many people as possible to also be interested in it, talk about it, and share ideas and ways to improve it. Also going to talk about bike ped crash CLE. What this does is it tracks pedestrian and bicycle and scooter related crashes that happen in the city of Cleveland that are reported to Cleveland 911. And the third one is something, if you've ever ridden a bike somewhere, usually the first thing you do is you try and figure out, where am I going to park this thing? What am I going to lock it up to so it doesn't get stolen? And some people may have experienced a scenario where there's literally nothing to park your bike to. So this is kind of just a really kind of one-off project where I just wanted to have this bot monitor OpenStreetMap, which is where these type of amenities are often like tracked, and just announce it to the world through Twitter. So let's jump into some of these. All of these run on AWS, Amazon Web Services. They're all coded in Python. AWS and Python, it just had the best Google search. If you Stack Overflow, it's just so easy whenever you have a problem to just Google it and find the answer. It was just really intuitive to me. And a lot of this is also coded in HTML and JavaScript. Those are pretty accessible languages to get into if you haven't already or haven't dabbled in them. You can make some interesting things. Just going through some of here, this was something I didn't really go into deeply at the last one and I'm going to share some pseudocode as well. But some of the Python modules that I use quite often, which I keep using over and over and over again. So they're just so common and so useful. If you have any interest in Python or automation or any of this, these are some really good ones to just write down and maybe experiment with something that interests you. It doesn't have to be bicycles or local policy. It could be whatever your fancy is. Requests, LXML, EsriDump, Overpass, Tweepy, Zappa, Flask. If you learn these, you can do a lot of things. All right, the BillBot. If you want to follow what's happening here in Cleveland as far as policy, there is a way that you can do it. You can go to the city council's website and you can see this, in my opinion, not great looking website. It's very, very old. And you can kind of click through and you can sort of search it, but maybe like 50% of the website's broken and you have to like constantly be going to this page to learn when anything is added. So basically, all of these projects are me making public data, open data, more digestible, more accessible, more interesting, more shareable. So what I do is I start from the original data, and I'll just take one piece of legislation here as an example. This was an ordinance from our current mayor, Justin Bibb, to basically reorganize and rename one division of city government into what's now known as Urban AI, Office of Urban Analytics and Innovation. There is an attachment there linked to see like what's the actual legislation look like. And this just like isn't easy to find. You won't find this in a Google search. It's not indexed. You just have to be a crazy person like me and just be constantly watching it. And this was something I did not want to do every hour of the day. I didn't have time, but I felt like it was important enough that somebody should, like maybe somebody has time. So what this Twitter bot does at a very high level is it translates one form of information into another form of information. A Twitter bot just seemed like something that was going to be useful, at least to me, because I spend enough time on Twitter. And a lot of other people who care about policy also seemingly were on Twitter all the time. So basically, it just takes various parts of this original data and it creates a tweet, it creates a link. You can share it, you can quote tweet, you can like it, whatever you want to do. Now, at a pseudocode level, this is going a little bit deeper and I don't have the actual code to share because that would just be too much on the screen, is what this bot does through Python is every 15 minutes, it scrapes the HTML page and it parses it, reorganizes it, and then it tweets it on Twitter. It's not that complicated. It's sort of complicated, I guess. Not really. It's maybe like 75 lines of code. And here's just some examples of how it's being used. All three of these that I'm going to show you today, I have no idea what's going to happen. I just launch, just try, just see what happens. And what ended up happening is that the Billbot, this automated Twitter account, was actually checking city council legislation far more often than anyone else at the time, than any local reporters could do on their own. So often it would tweet things that nobody else knew yet, other than city council people themselves. So this Twitter account constantly was out scooping our local government reporters. And kindly, these reporters would just retweet them and give some attribution. And a lot of times these are like big pieces of legislation, there's millions and millions of dollars, and people could finally like know that it's happening in real time. And local policy and legislation move so quickly that the faster that this information gets in the community, usually the more influential that ordinary people can have some sort of say. They can reach out to the council person's mayor's office. They can have some sort of impact. Next one. This is what the city of Cleveland puts out on their GIS accounts. All of these little icons are basically GPS coordinates of where someone has called in a 911 call. It could be a light that's out. It could be a robbery. It could be a water pipe that's exploded and spewing water everywhere. This by itself, it doesn't tell you a whole lot, just intuitively. As far as a map design, it's not the easiest to really navigate or figure out what this map is trying to tell you. This is just big data with no meaning, really. And with all these, trying to figure out like, what is the meaning? Like, how can I actually use this to have a discussion to figure out, is this good? Is this bad? Is this improving? Is it not? If you were to click on any one of these points, just as an example, all it says is accident. There's lots of different kinds of accidents. But one of the, so basically what this tool does is, again, it's a translation of one data set that I just personally did not like, and I found it hard to use, using tools through Python and the different modules that I listed before, and basically translating it into something that was a little bit more informative. So we know with this one that this is some sort of crash. A driver hit someone on a bike or on foot or on a scooter, and it shows a Google aerial view of where it was. It shows the neighborhood, date, time, who the local representative is. If someone needs to reach out and be like, hey, this is like a not safe place. Like people are always speeding here and crashing. This is, I'm going to give a quick example too. One of the things that I listed, which is, it's going to be on the next slide, but generally, if you ever see an ArcGIS map, so in the corner there, it says Esri. If you want this data, you can download this data. It's not intuitive, but there is tools out there that allows you to extract it. So if you are looking for an idea for a class project, or just some random thing that you want to see if you can extract meaning from data, find an ArcGIS map. Usually you can quite easily pull down that data here. Anyone uses developer tools, which is a great thing. You can kind of look for network traffic in your browser. Definitely Google that. If you filter your search like REST/services, that exposes the URLs of the APIs. That might be a bunch of weird lingo for people. But basically these expose the data sources that you can then pull the raw data from. Here's some pseudocode here from that map here. Again, this is Python here in this black box. This is very high level what it looks like. You just basically need that URL. There's also command line tools. So it's just typing like Esri to GeoJSON, if anyone's used that type of spatial format, and you can download a geospatial file, and then you can plug it into your favorite mapping software. Sorry, I'm a mapper, so I'm throwing a lot of mapping terms, but I'm sure it resonates with some of you here. So yeah, it filters the data in the pseudocode. It generates this aerial map using Google Maps API, and it tweets out the info. And again, through that translation, it allows people to engage. It allows people to like understand it, to see it, and to share it, to comment on it. So some people see the crash that's tweeted about. Some people tell the history of an intersection. Other cities have copied this, which is pretty cool. A really great improved version in Atlanta. Other people have done stories kind of on the data because it does affect so many people. Bike parking, this one uses OpenStreetMap. OpenStreetMap is almost like the Wikipedia of geospatial data. It is used commonly for route mapping. If you're driving your car, a lot of the big mapping services are pulling in data in some form or another from OpenStreetMaps. This one tracks bike parking, so a bike rack. If you're ever looking to park your bike, this tracks every time new bike parking is installed. I think in theory, like the more bike parking, the better, because then more people can ride bikes and have less cars and have less traffic. So this was just purely just a random project I wanted to try. Again, it translates data from one form, which is just kind of this map that's kind of hard to filter and query, into one that provides something to share, something to read, something to at least absorb quickly. And it also gives people an opportunity again to provide context, like what's the story here? So here's just one example of something in Gordon Square over on the west side. Overpass is the Python module for querying OpenStreetMap. OpenStreetMap is huge. It has so much information. You can pull so much interesting data. Again, if you have a project, if you're in geospatial, if you're looking for economic development, like community development, where are there hospitals within a range of these certain census tracts? You can pull so much great data from here. And this is global. This is global data, every country. So it's very comprehensive to use. And again, here's some pseudocode. If you enjoy Python, or if you want to learn Python, this is a good little shortcut to get you started here. Here's some examples, again, of providing people an opportunity to provide feedback to the data. So it's one thing to just have data, but data on its own does not have much value until a human can figure out, is this good, is this bad? So here's just some different people providing comments. Is this bike parking in a good place, a bad place? Should there be more or less? That is all the talk. I went through that really quickly, and I want to open up for some questions. What do we think?
Got a question
Yes.
online.
Oh, okay.
Curious how much it costs monthly to go to church.
Oh, it's like 0. Maybe like 1 penny, 2 pennies. It's very, very cheap. AWS, one of the great powerful things AWS said, it's so cheap. You're not setting up servers. There's so many resources online. It is very cheap. I have never liked managing, maintaining, or setting up servers in the cloud or anywhere else. The great thing about AWS, I'm sure Google and other cloud-based providers have this capability too, but it's extraordinarily cheap. With a Twitter bot, you're also not like storing that much data. It's just in and out. So it's really just the computation time, which is a millisecond.
Follow-up question, did you use serverless for this, or you're running it?
All serverless. So this is running on Lambda, essentially. So Zappa, Z-A-P-P-A, is an excellent Python module. And Flask is another great one, especially if you want to set up any sort of outward-looking like website that you can do templating. It's very simple to use. I highly recommend it. Thank you. Yeah, serverless is the way to go. There was a question in the back over there. The question is, what's the geographical area of the bike parking monitors? So all 3 of these projects, I live in Cleveland. So when I built these, I'm like, let's just track Cleveland. So these are all Cleveland specific. The bike parking CLE, you can tweak that code to monitor any region, any city, any county, like anywhere. So if you want to set one up for any other city, you can do that. And that code is online on my GitHub. Not all of these are, because I'm just a disorganized person, but the bike parking one is. You can download that if you know how to use Git and GitHub. You can set that up yourself. That would be really cool. Let me know if you do that. Give me a shout out, because I would love to see other cities doing this too. I see another question in the back. My GitHub is just Trivisonno, just my last name. Do I even have my last name in this? Is it on the first slide? Yeah, okay. It's the same as my Twitter handle. So if you just go to github.com/Trivisonno, you can find a random collection of a few of my projects. Again, not all of them are up there. I'm not a professional coder. So you're going to see a lot of poor, not best practices for me if you look through my code, but it at least works. I'm a very much a minimum viable product type of person. Raise hand there, yes. I think it's case insensitive. I think it's lowercase. Okay, then it's a lower. Try lower. If not, try the upper. Yes. Yeah. Yeah. Great question. So the yes. So the question was, what was the development time kind of invested into setting up these bots? Great question. I did not keep track. Probably many nights. I'm sure many nights. I did not keep track of it. Cool thing is that once you build one, you can just recycle code over and over again to kind of figure out. And for making a bot, it's to do a tweet with Python code, it's maybe like 5 lines of code. It takes far more time to figure out what you want the bot to say. You have all this data. What does the data mean to you personally as someone writing code, and what do you want it to mean to someone else that you're building a product for? So yeah, and there are some websites now that I think will help you program a bot without needing to know how to code. So I think there's that like growing capability. And then finally, I guess just as like a final thought from me is what's the next step with these Twitter bots? Twitter has changed, at least since I gave this presentation the first time back last year. And Twitter has fundamentally changed a lot of its algorithms and what it wants to show you. So from me, I need to figure out, is this the right way to translate data into something that's useful? I don't know. That's just kind of me sharing kind of my thoughts. I don't know if I'll make more Twitter bots. I don't know if Twitter bots are the right way to kind of make an impact. I know a lot of people use them, but I think everybody's trying to figure out, do people want to stay on Twitter? Do people want to keep building products on this platform? So yeah, it's definitely a cool thing to learn how to do. And I think it applies to a lot of different services too. Yeah, Doug, sure. Great.
You talk about automation for deployment of your code.
Okay. Yeah, can you talk about automation? So the question was, can I speak a bit to the deployment of the automation of the code? So I guess just acting it out here. So I'll type some changes, type some code, technical poetry, and in command line, basically use Zappa. Zappa, I mentioned it before, it's an excellent deployment package, and it just combines everything and it launches it into the cloud, and it's immediately ready to run. It's like magic. If you dabble at all with Python, definitely check out Zappa. It's literally Zappa deploy dev. It's like 3 words. Click enter and you're good. And that's how you do updates. Just Zappa update dev. It's incredibly easy to do. I encourage all of you to try it. If any of you try it, reach out. I'd love to see your work. And thank you so much for your time. I appreciate it. I'll be here afterwards. Thanks.
Cool. Next up is Sean from Databricks. And again, I have to issue an apology to Chris, the first speaker, because while we saw his presentation physically here, I'm told from people in the chat that we finally got working, they were seeing the thank you slides. So they said they heard Chris fine. That's because I forgot to stop sharing my initial slide deck. So sorry about that, Chris. But they said they heard you just fine. Are you going to be posting the slides? Okay, yeah. So we'll get those slides posted. Chris said he'll share them. So yeah, we'll get those things posted somewhere.
Says you can't start your video because the host has stopped. I'm trying to share. Try again. Now it's letting me. There we go. Should be sharing.
Yeah, I can see I'm seeing exactly that, so let me go full screen.
All right, let me slideshow it here. How do I minimize this guy?
Move your cursor off it.
Up here? You said this green portion? All right, good enough. So, yeah, good to meet everybody. My name's Sean Carruthers. I'm part of the account team with Databricks. So gonna walk through, as Doug mentioned in sort of the introductions, what Unity Catalog is with Databricks. But even before getting into doing so, gonna touch a little bit on who's Databricks. I'll go through sort of a slide of who's Databricks. We are a startup, third largest unicorn startup company, only behind SpaceX and Stripe, based out of San Francisco. And really talk about how that came to be, why Databricks is the company we are, what lakehouse really means. You probably heard the term, or many of you probably heard the term data lakehouses, what that is, because Databricks is a pioneer of that and really is what has drove Databricks to the success and the valuation that we are at today. So, and then getting to the topic discussion after that is Unity Catalogs. The Databricks released Unity Catalog to provide this centralized governance layer across workspaces, across cloud providers, et cetera. So I'm going to try and get through all of that. I know I'm the last speaker, so if you have any questions, grab me in the hallway. I'll leave some cards. I know, Doug, you mentioned you'll be sending my contact info, things like that. So anyone listening virtually, feel free. So who's Databricks? So Databricks is the data and AI company. So we are the inventors and pioneers of the lakehouse paradigm, which more or less offers one simple platform to unify all of your data, all of your analytics, and all of your AI workloads. Gartner recognized Databricks as a leader in 2 quadrants this past year, a leader in database management systems, as well as a leader in data science and machine learning platforms. Kudos to our platform team. We are the only cloud agnostic tool to be recognized as a leader in both. So good for them. Our CEO and co-creators are the founders of a lot of successful open source projects like you've probably heard of, like Apache Spark, MLflow. They are the original creators of these open source projects and pretty much the birth team of Databricks, if you will. So we work with over 6,000, 7,000 plus customers today. This slide's growing daily. And it's been built around this concept of open source expressed through some of the most successful projects, as I mentioned. This more so than the familiar logos that you see here is just giving you an idea of the amount of and different companies and industries we're working with today. You know, when you say data company, you think of the Twitters, you think of the Teslas and Googles, but really every company is becoming a data company today in some sort. Leveraging data to improve customer experience, to improve manufacturing processes, you name it. So this is more so just showing you how really every company is becoming a quote unquote data company today. If we look at kind of how that's happening, I like to break it down with this slide here. We call this the data and AI maturity curve, where if you kind of really look at this slide, it's how companies are leveraging their data and AI today to really expand their business, to improve customer experience. And really the left-hand side of this graph is really your traditional data warehouses, where we're capturing data, we're looking in the past, hey, what happened? What was our customer churn rate? What were our sales last quarter? You name it. The right-hand side of this graph is where we're really looking into today's data lakes, where we're getting to more of our AI, more of our data science models of, hey, what will happen? Or how can we, create responses based off of things that we know what will happen, and really getting more proactive with our data versus reactive. And obviously, a lot of the leaders in any industry are trying to be as far right on this data and AI maturity curve as possible. There's some issues, and really that's kind of broke. If we split that graph in half, as I mentioned, really the challenges most companies are having is that they're implementing 2 different systems in order to really drive these game-changing results. As I mentioned, you have the data warehouses for BI and your data lakes for AI and ML. But at the end of the day, these platforms are incompatible with each other, but you generally need data from both of these systems to deliver the results that you're looking to, which makes success with AI in any industry, in any organization difficult. But if we look at, kind of reasons why this happens, is first, you have duplicated data in 2 different systems. So changes you want to make in one system may not find their way to the other. So you start to get data drift almost immediately. Then because governance is happening at two different levels across these platforms, you're not really able to control things consistently. And that's where we'll talk about Unity Catalog here in a second. Finally, there's two completely different tool stacks built on each of these. So you have a tool stack built to do your AI, your tool stack meant to do your BI, different teams working from different sets of data drift between the teams, really creating this, sort of complex system, if you want. I'll build out the slide here a little bit. That's at the end of the day, the heart why AI, at the heart of it, why AI fails at most organizations today. Really this complexity of data drift, of siloed teams running two completely different systems to really try and kind of get game-changing results. And that's where Lakehouse comes about. Like I said, most of you probably have heard the term Lakehouse. If you haven't, it really is, as the name sounds, as simple as it sounds, taking the best of a data warehouse and the best of a data lake, hence the name Lakehouse. So you're able to have all of your data, structured and unstructured, in one place. So obviously, first and foremost, you're simplifying your teams. All of your data engineers, your data scientists, your analysts are working under the same hood from the same set of data, limited context switching, et cetera. Then we bring reliability and extremely fast query performance to that data without leaving the lake with an open source technology called Delta Lake. It's that first blue wave you see above the cloud providers there at the bottom. I like to think of that as really bringing your speed and reliability that you're used to at data warehouses to your data lake. That's really sort of the back end engine of Databricks Lakehouse, is that Delta Lake layer, if you will. Next, Unity Catalog, what we're going to talk about in the most detail today, provides the unified governance for all of your data with one consistent model. And then we offer, purpose-built tools to allow everyone to collaborate on that same data. So really, if I'm just summarizing what, the advantages of a lakehouse versus a traditional data warehouse / data lake, approach or methodology is first, you're dramatically simplifying your data architecture for all of your workloads. Second, the entire platform is built on open source and open standards, like I mentioned. It means you have, a lot of freedom to evolve your strategy or evolve based on your current tool stacks or environments. Finally, get one consistent experience across all clouds. Databricks does not store any data. We are built on top of your cloud storage, S3 or AWS Gen 2, however it may be. And you get the same experience across clouds. I think about 70% or 75% of the large enterprises we work with today are hybrid cloud to some extent. So if we click into this and get into that sort of next layer above Unity Catalog and get into the governance piece, I thought this was a pretty interesting fact of 80% of organizations, seeking to scale their digital business will fail strictly based because they do not take a modern approach to the data and analytics governance, which is pretty surprising. But if we look at, let me switch here, build this out. Kind of why that is there's a reason for that. So data and AI and governance today is complex because of a lot of complex data stacks and diverse data teams, et cetera. So the typical organization, you have a lot of data stored in data lakes, as I mentioned, in your cloud storage, for example, S3 or AWS Gen 2, whatever your cloud vendor may be. Governance on that data lake has its own challenges. Cloud data lakes generally only set permissions at the file or directory level, making it hard to share, just a subset of a table with particular users. This makes it tedious, to onboard new users who should not have access to the whole table and things of that nature. So also the lack of centralized metadata management results in poor data discovery for data teams. And then operational overhead to identify data resources in data lakes makes it difficult to audit and meet compliance requirements as well. That's where Unity Catalog comes about. It was that wave on the previous two slides. So really, Databricks created Unity Catalog to address these challenges, which gives a unified governance layer for all the data and AI assets in your lakehouse. So simply put, Unity Catalog provides a single interface to manage permission or auditing for all of your data and AI assets. So if you kind of look at what some of the advantages of it are, really it provides a unified stance on governance across clouds, as I mentioned, across your workspaces as well. It helps your organization be compliance and audit ready. It works in a performant manner to meet enterprise at scale. And it can seamlessly integrate across your modern stack as it is API first. You're able to create a unified view of all of your data estate. So catalog all of your data assets and scalable centralized metadata management. You're able to centralize your user identity management and gain visibility of who has access to what, be it geographically or maybe different groups within your organization in different locations, et cetera. And Unique Catalog also offers fine-grained access controls on tables, files, rows, columns. So you're able to kind of break it down to however your organization or your team may need. With built-in lineage, data teams can get an end-to-end view. So you're able to understand how data is being consumed and who and by whom with centralized fine-grained auditing, as I mentioned. Also, you're able to securely share data across platforms, clouds, on-prem, whatever platform systems you're working with, you're able to easily share your data across any of these systems. And there's no compute charges, so we're eliminating data replication, built-in, there's also built-in data search and discovery. So you're able to do that directly through the platform, directly through the Unity catalog piece, without having to bounce around more or less. Actually, one of the, if I'm having trouble clicking, one of the most recent releases as part of Unity catalog is the feature with data lineage. So now we have the ability to automatically capture runtime lineage on clusters and SQL endpoints down to the column level. So that means if you create derivative data set based on another data set through Spark APIs, you'll be able to see that relationship through our UI and through our APIs. So pretty cool, unique feature. And we could talk for an hour on that alone, but just trying to give you guys an idea of kind of what all is entailed. And really the last piece here on the Unity catalog is just seamless integration across your modern data stack, which kind of falls into the open source piece I mentioned earlier. Open and simple. So really in a nutshell, Unity catalog, to simplify it, is a unified governance solution for all of your data and AI assets, including files, tables, machine learning models, and dashboards in your lakehouse, sitting on any cloud piece. I'm going to pause right here and see if there's any questions for anyone. I don't know, Doug, if you have any online or anyone in here.
Don't see any, why. I did have questions. I did have a question about how do you get in the lineage things to show up in terms of dependencies? So what has to happen for that lineage to be known? Does that make sense? But table one, so if you go back a slide or two, you had table one, you had table on the left, and you have a line, and you have a table. What has to happen?
Here?
Yep, there we go. The thing that goes to dependency.
Yes.
So what has to happen for the table on the left to create a dependency on that next one, to create another dependency on that? Like, what do you have to do specifically?
Yeah, and I can show you the technical answer to that as far as how you can build that out. But it's all built out kind of, for lack of better words, to your discretion, kind of how you want it to be built out. But if you want to grab me in a second here, I'll show you. I've actually got a document that'll answer your question perfectly. But yeah, the layman short-term answer is it's kind of based on discretion, and as well based on kind of what you're trying to achieve from that piece. But yeah, I'll share that with you here when we wrap up. Yeah, I think there's another question too. Yeah. No worries. Yeah, so really with data lineage, you're able to capture, simplest way to say it, you're able to capture like runtime data, runtime lineage on clusters and endpoints, like I mentioned. So that means if you're trying to create a data set based on another data set, through Spark APIs, for instance, you'll be able to see that relationship through the user interface, if that makes sense. Does that answer your question? Okay. Any online, Doug? I wanted to keep it kind of high level, but like I said, yeah, feel free to grab me. I'm more than happy to answer any other questions. And yeah, I really appreciate everybody's time.
And Sunny from Cleveland State, who's hosting us for this, you wanted to talk for a couple of minutes? Yeah, we've, the main speakers are done. Now, if you wanted to also talk to some folks online, I can bring my laptop up there, because I'm or just to the folks here. Super. Let me no, it's okay. I'll just here. You want to present something?
No, yeah. This is-
Oh.
no, but I can.
Okay. Let's, you don't have a speaker link, so just do a, just go ahead and then present from there. Okay.
Yeah, just access to this web.
CSU, hang on.
Just SS. Oh, okay.
Yeah. Um,
Yeah.
all right, go for it.
Sorry about that. I was gonna start with welcoming. I was a little bit late. I have a two class. I have class at the same time, so I arrived late. So welcome to the CSU, and I'm very happy to see all these folks, our Big Data group, in person. So we are resuming. So CSU, we usually hosting the Big Data group once a year in January. And then, yeah, the old history with Doug. We used to have 200, 300 the attender here. So I'm really happy to resume this. Just to couple of announcement for what is going on and in terms of big data and then data analytics, big data analytics and AI with machine learning to build AI applications. These are of course exactly our presenters is presenting in each use case, but here I just wanted to introduce a couple of things going on in CSU in terms of this area. So the research on these are our big data lab website, and then so I probably have to post it this. The chat for you to access it.
We'll post it.
Oh, all right, so you will post it here.
Yeah.
So,
I'll make sure it gets out.
Right.
Send me the links afterwards and I'll get it.
right,
to the meetup group.
all right, so these are, so can you do?
So, yeah.
Yeah, just, if you
Yeah,
could just do
all
the
right,
quick.
all right, so these are research area, selective research area, but of course, right now, it's just a lot of them. So a lot of them is text analysis of natural language processing. These are building AI question answering system like Alexa, or just very simple application of the Twitter bot is a very small the AI application, but we are bigger levels of 30 million the biomedical web the research paper. So based on that text the text processing, and then capturing the knowledge, how to represent and store the knowledge in the 30 million biomedical research paper published in last 30 years, and to build question answering system just like Alexa-like, not just based on voice-based, but of course through the web-based Alexa-like question answering system, which is true AI to help the doctors diagnose the complex their patients, and then treatment, and then so these are just currently going on, and the NASA is interested in this to build their own the chemical engineer based the paper research paper processing question answering system. So and then of course machine learning based a lot of learning the fraud detection, intrusion detection on 20 different cyber attack, automatic the identification detection system, part of that through the deep learning. These are all right now currently active the research in this big data lab with my 3 PhD students. And then a lot of Twitter analysis, so real time the opinion analysis in product review, and then presidential election prediction last year 2020 for 7.2 million tweet pre-election tweet, and they actually nailed it down to build the predictive model to predict correctly, even for 51 versus 49% of. So these are currently going on the big data lab, and then we are working on collaboration with doctors, the neurologists actually, in the Case Medical School, and then University Hospital, and the VA hospital to diagnose just schizophrenia or brain injured the patients, so predictive model, and then so really truly the big data analytics to build the AI, which is the all yours, our audience is interested in. So I wanna introduce these are the research going on in Cleveland State, and at the same time we have the data science the program in the undergraduate level, so BS. So bachelor's degree of data science program is I actually finally we spend a lot of time to create curriculums and then got the approval. So now in the act-on, so we got the first year of data science program, and then we have a PhD in this big data analytics and then AI, and then data science is officially under the computer science curriculum. So anything, if you wondered where to go to start, this is the place. I'm just announcing these happy news. All right, and then I will pass it to the
Awesome.
this the Doug.
So again, I want to thank everybody for coming. Wow, this is actually a really good crowd. Let me get one more picture here. This is, I'm really, really grateful for everybody showing up because I wasn't sure who it, post-COVID was actually going to be. This is really fantastic. Fantastic crowd. Yeah. Again, we've got next meetup in May, I'm sorry, March and then May, and so you can, if anybody has any topics to suggest, please hit me up. And again, thanks for coming tonight and yeah, safe driving on the way back. Thank you. Have a good night.